Lesson is on overlapping triangles, and basically it's the same concept as the stuff we've been doing. However, some of the diagrams, as you'll see here, the triangles that we're trying to prove congruent cross over each other, so it may be hard to find the parts that you need, or even hard to label them. So one of the tricks we're going to see here is to redraw the triangles separately. And once you redraw them separately and label the parts, it's a little bit easier to see. So we'll start with this first one here. And if you look at the triangles we're trying to get congruent, we have SXT and SYR. So they overlap in this kind of top diamond looking shape here. And we're trying to get them congruent, so it may be easier to have them drawn separately like I mentioned before. So I'll do that here. I'll draw this triangle. I know it's not going to be the best one here. Actually, hold on. I'm going to retry this one. All right, hold on. Let me give this a shot. Okay, so this would be S, Y, and R. And then down here, I'll just draw the other one. Definitely a lot easier maybe than it looks, but well, not really. It's kind of tough. But anyway, okay, so here are the two triangles, and by drawing them separately, you can kind of see the parts individually. So I'll label on here SX, which is this piece, is congruent to SY, which is this piece here, and SX is perpendicular to XT, so you have a right angle here, and SY is perpendicular to RY here, and right now it kind of appears that we don't have any other givens to give us parts. So one of the things we look for a lot is a reflexive piece, and usually we have reflexive sides, but if you look at the way that this is labeled, S, R, and Y, and S, X, and T, there is no matching piece, right? ST does not match SR, it's not the exact same thing, so they really don't share a side. But one thing they do share is this angle S at the top. And you can see angle S is the same angle S right here in both diagrams. So for this particular problem, we have a reflexive angle. Angle S is congruent to itself, and you can see that these two triangles would be congruent by angle, side, angle. So I'll go ahead and write this one up, and we'll talk about how to put all of this stuff into proof form. Okay. So for the first step, obviously we're going to put our givens. So let me just make sure this is going to stop. There we go. We'll have things such as, Sx. I'll do this actually in equation editor here. Sx is congruent to Sy. These in caps. Okay. So you're going to write this stuff in, and to kind of speed things up, I am literally just going to copy this and paste it in there. So these are the givens. And there we go. We have given. This will speed up in a minute. So the next thing we're going to have here, after we have our givens, is, let's see. Well, we can pick any of these parts that we kind of labeled. So SX congruent to SY is already there. I do need to call these right angles first. So I have to say things such as angle Y and angle X are right angles. So let me just quickly go into my little angle symbol here. So we have, obviously a lot quicker for you to write it, angle Y is congruent to, and let me go back to this. No, I don't want to say congruent. Sorry, I actually want to say angle Y and angle X. Come on. There we go. Angle X are right angles. So anytime you get perpendicular, you want to say that the angles are right angles. I know this is going to give me that numbering thing again. And let's stop that. Oh, that's going to stay there. Should have moved it over before. And the reason for this is definition of perpendicular. And this is something you're going to see in a lot of proofs. Anytime you're getting right angles or perpendicular lines, you want to say that they're right angles. So that's definition of perpendicular. And third step here is to say that angle y is congruent to angle x. So I'm going to say angle y is, let me go into my equation thing here, congruent to, and then I'll put an x there. Angle y is congruent to angle x. And the reason is all right angles are congruent. And you could use the congruent symbol, but that's just faster for me right now. All right, the fourth step here is going to be to name angle S congruent to angle S. So I'm going to say angle S is congruent to, get the congruent symbol, itself. And this is reflexive. Get a little extra space here. And this is what a Microsoft Word does to you. It always tries to make you have a numbered list. And this is reflexive. It's really a reflexive angle, but we'll just call it reflexive. It's congruent to itself. And if you see now, we have angle y congruent to angle x, angle s congruent to angle s. We already had sy and sx congruent. So now I can say in step 5 that the triangles are congruent. And let me just get that here. Triangle sxt. Probably just copied and pasted that, but that's okay. It's congruent to triangle SYR. And the reason for this is that angle side angle, do this in here, angle side angle is congruent to angle side angle. Sorry about the the typing out of all of this in the beginning, but I think we got it to work now. Let's try, maybe this will look better. There we go. So that's our first proof, and as you can see, the write-up wasn't too bad on this one, but you have to redraw the shapes, and when you redraw them, sometimes you have to be able to find this reflexive angle, which is not necessarily an easy thing to do. I get that. Just want to make sure making sure this is recording here. Yes, it is. Okay. All right, so if we go to this next proof, kind of dealing with the same thing. This is similar because it's got the perpendicular in there, so I'll leave that one for you to try. Let me go to this one. This one does not involve right triangles, so this one does again, and I just want to see something really quick. Okay, yeah, just when you do number 2, just make sure you notice something about the bottom of these 2 triangles down here. All right, so you could try that one out, and I can go over that one with you when I see you. Number 3, well, first let me just split this, and this would be our statements and reasons. Okay, so on this one, you can start drawing this one separately and kind of seeing what that gives you here as I'm formatting this. Okay. All right. So here, what we have is 2 overlapping triangles again, and it's good, to be able to redraw it and see where they are. Sometimes there's multiple triangles. If you go back to this problem here, you can see there's multiple triangles in here. There's these two top and bottom. There's the big one overlapping here with CBA down here. Then there's this one, DBC, with BADC. So there's a lot of triangles. Sometimes it's hard to figure out which ones they are until you redraw it. This one here, I think you'll be able to see it pretty easily. We got triangle BAE and triangle BCD. Actually, yeah, there's a couple. There's the overlapping ones at the bottom too. So I'm going to redraw these. Again, not so easy to do with this mouse, but I'll give it a shot. We've got triangle BAE and triangle BCD, which would look like this. And you get the picture. So this is B, E, and A. And this is triangle B, D, and C. Okay. And if you go ahead and label everything as given, BEA, you can see that angle is right here, is congruent to BDC, which is here. And that's not necessarily a right angle, even though I made it look like it. So let me redraw it. There we go. And EA, which is this piece, is congruent to DC, which is at the bottom. And now you're looking for another piece. You're out of givens, right? These are gone. So you need something else. And if you kind of look at the triangles, you can see in the big picture, angle B is something that they share. It's an overlapping angle, kind of like the one we just did. So you're looking at an angle, and side proof. It's the order that these go in. And if you need help still determining which is which, angle, side, angle, side, I can help you with that. When I see, yeah, so we have these as our givens. Put these in. And we have, let's see here, there we go, put this there. These are givens. And what we need to do now after we have our givens in is put that last piece in, which was angle B congruent to angle B. Really, this is pretty simple proof because we already know that we have the two angles and the two sides given to us. So essentially this one is kind of a no-brainer. This one's just going to be that, copy this little angle symbol here. We have angle B is congruent to angle B, congruent to itself. And this is going to be reflexive. Of course, it's going to keep doing this to me. There we go. And this is reflexive. And finally, I know it seems kind of crazy, but really we have everything we need here to get these two triangles congruent. So I can say that these two triangles are congruent to each other. And this is angle, side is congruent to angle, side. So I'm going to just come up here and steal this one. Probably could type it out faster, but that's okay. So really the importance of this lesson was for you to be able to just kind of see how you would redraw these pictures in order to get what you need. And when you redraw them, I think it stands out a lot clearer. However, the tough part ends up being seeing the reflexive angle, noticing there's a B here and there's a B here, and that it was the same in the original picture. You can try, question 3 and question 4 out. This was really more just practice along the way as we were getting through our basic proofs and adding in a few things like perpendicular that you see here. So you can try 2 and 4, see how they do for you, and if you've got questions on overlapping triangles, you can let me know. But the key, redrawing them separately and labeling the things that you have. All right, good luck with this one.